Hello everyone, and welcome to the second part in this series of videos exploring qualitative coding. My name is Amir Mikhailovich, and I'm a consultant for UBC Library Research Commons on Computer-Assisted Qualitative Data Analysis, otherwise known as CACDAS. In this video, we will explore categorization and code hierarchies in Computer-Assisted Qualitative Data Analysis. I will be exploring some of the ideas in NVivo for PC, which is a CACDAS package that UBC currently makes available for free for students, faculty, and staff. All of the concepts and processes that we will cover in these videos apply not only to NVivo, but to many other CACDAS packages such as AtlasTI, MaxQDA, and many others. For an overview of different CACDAS packages, see the link in the comments section to the UK-based CACDAS networking project. Our objectives for this video are to consider some of the purposes of categorization in general, and then more specifically for qualitative data analysis, or QDA. We will then explore code categories and code hierarchies in Computer-Assisted Qualitative Data Analysis, or CACDAS. Lastly, we will review some tips for creating and managing code hierarchies. Let us first consider what categorization might be useful for in the first place. As Pare claimed, citing Boker and Starr, our ability to categorize, to identify similarities and differences, allows us to reduce a potentially infinite number of instances into manageable classifications. As Melissa Freeman argued in her book, Modes of Thinking for Qualitative Data Analysis, the primary purpose of categorizing is to identify the criteria for determining what something is made of, or is part of. Blanchette provided an important perspective on categorization when she argued that the only reason why we think of categorical thinking as more logically compelling is that we feel more at home in it, as something of our own making. Moving on to categorization for qualitative data analysis, Maxwell claimed that categorization is treated in most accounts as a fundamental activity in analysis. Categorization involves comparing data segments and looking for similarities, as Susanna Fries, a CACDAS expert, claimed in the quote here. But importantly, she also added that as we group similar elements together under the same name, we both conceptualize and frame this collection of elements or segments at the same time. This is a really important point about the importance of the labels we use for our codes, as we explored in the previous Part 1 video about coding. But categorization has limitations and downsides. Researchers in different fields have claimed that, for example, categories mask diversity and obscure the nebulous quality called context, because it often involves taking segments of data out of their context and collecting them together under a certain label. That is why Maxwell and Schmiel and Maxwell and Miller have argued that categorizing strategies are often conducted alongside connecting strategies, which involves seeing connections between concepts or pieces of data in context. So after we placed categorical thinking in the processes of qualitative analysis, let's delve a bit deeper and see how categorization can support our coding processes. Lynn Richards, in her book Handling Qualitative Data, suggested that the fundamental question in categorization for coding is to ask ourselves, what is this data segment a sort of? And why am I interested in that? Which highlights that a code must have a purpose. Next, we move to Jackson and Baisley's examples of coding categories from their book Qualitative Analysis with NVivo. Looking at this small selection of code categories that they provided in their book, we can think of types of code categories for actions, and then subcodes like argue, cheer, laugh, or listen. The same goes for context as a code category with subcodes such as school, work, and then the category of feelings, and so on. An interesting example that may apply to different research projects is the code category valences, or attitudes. Subcodes of this code category may include negative, neutral, positive, conflicted, or uncertain. A simple research question that such a code category may help us address is, what are people's attitudes toward a certain issue? Then we might have a code category or code family for the subcodes of attitudes, and then another code category for the subdimensions of whatever issue we are addressing in our research question. But beyond codes with subcodes that essentially look like categories with subcategories, we need to remember that many useful codes may not necessarily follow a categorical structure, like codes collecting salient quotes, participants' recommendations, their suggestions, etc. Such codes are really important because if, for example, in the future we would need to pull all of the salient quotes associated with certain actions, we would want to make sure that when we code our data, we apply on every given data segment the code or subcode of the category that it pertains to, but perhaps also another code or several other codes, such as the code salient quotes. Creating these intersections of overlaps manually will support us in pulling our data in flexible ways later on using Cactus software. One way to think about it is to think of your data segments as Lego blocks that you purposefully create in order to later on combine in all kinds of ways. So let's have a look at this in NVivo. The first thing I would like to show you is an example of a code list from the sample project that comes with NVivo, the Environmental Change Down East sample project. Once I open this project from the NVivo welcome screen, I'll go to the code section on the left-hand side and open two code categories, code hierarchies, or as we can call them, code families. Let's look at the family of attitudes and the family of economy. If you have a quick look at these two code categories, it would appear that one of the questions that the researchers had was, what were people's attitudes toward different types of economy? Addressing this research question entailed a strategic decision to build these two code families, one for attitude types and the other for economy types. For any given segment of data that the researchers were reading, a code was applied, if it was warranted, from the family of attitudes, and another code from the family of economy. So the researchers not only created subcodes or subcategories in their code list, but they also applied multiple codes for any given segment. These two practices are essential parts of using coding categories in computer-assisted qualitative data analysis. Now, as the researchers coded their data, they obviously had all kinds of ideas about the patterns that might be emerging from this data. For example, people's negative attitudes in relation to fishing or aquaculture. But they weren't going to test that assumption until they were done with coding, so they would not direct their coding in that particular direction or fall in love with it. They probably wrote about those assumptions and emerging thoughts in a research journal memo. But now, when done with their coding, it is time to cross-tabulate the code categories and their respective subcategories in order to help researchers address their research question. What were participants' attitudes toward different types of economies? For this, we will use NVivo's matrix coding query, which is a very common form of analysis tool that is available in many different Cactus packages. In the matrix coding query, we will bring in the members of the family or category of attitudes, let's say into the rows section, and then bring in the members of the family of types of economy into the column section. Assuming we want to include segments of data from the entire project, we will keep the default setting to search in files and externals in place. Now we'll click on Run Query and explore the results. We will add a bit of color to this table so that we can see some of the emerging patterns more easily. And voila, it looks like our assumption was verified. There did seem to be a lot of negative attitudes toward fishing or aquaculture. We can also change the cell content by right-clicking on a cell to switch from numbers representing data segments or references, which might all come from one participant, to cases of people, which would tell us how many people had these negative attitudes. As the pattern is somewhat similar, we can now move from this insight about prevalence of these attitudes toward fishing or aquaculture to explore how people discuss that type of economy negatively, and move our analysis forward from there. As we saw with this example, it really does tend to help when you code each passage to multiple codes that are all relevant rather than create an overly nuanced single code that attempts to capture all of that content at once. By using this approach of applying multiple codes from different code categories, we can later check whether combinations of codes form any kind of pattern. This quote, again, is from Jackson and Baisley's book. To approach this important tip from another perspective and offer a rule of thumb, make sure that each code, category, concept, or theme appears in only one place in the coding system. This is because when we look at the code list to the left, where categories and subcategories are mixed and duplicated, with a set of attitude codes nested within every type of immigration code, we have a lot of codes being duplicated. So we begin with an unnecessary long code list, which invites more mistakes. We also have somewhat less flexibility for addressing new, unforeseen questions. because we only coded for very specific things nested within other things, like a negative attitude toward past immigration. And importantly, when we already see the number of references or segments of data for these nested codes as we conduct our analysis, we might find ourselves falling in love with a pattern that is not there and focus our coding in that direction. On the other hand, if we work with the code list on the right, which separates families or categories of codes and necessitates the application of multiple codes for any relevant data segment, we kind of distance ourselves from what we think might be the emerging intersections of the different code categories, because we can't immediately see the frequencies of segments associated with them until we set up the matrix coding query, or that cross-tabulation of different code families or categories, which is useful to do when we are done coding. In that way, we have less codes on our list, which means we might make less mistakes when searching for or creating the right code. We will also have flexibility for addressing questions that were not initially foreseen, because we would be coding anything attitude-related or immigration-related without being too narrow with nested codes with very specific meaning. This will buy us some clarity and systematicity as well that are important in research practices. And just to summarize this, here's a reminder of that rule of thumb that Jackson and Baisley mentioned in their book, namely that each code, category, concept, or theme should appear in only one place in the coding system. With that, we are wrapping up our second video in the series. I invite you to join me for the third and last part, which will discuss tips for qualitative coding.